Hey, this is Alex, and I'll be talking about Gauss's law, particularly the local version of it. So, we all know that we define the flux of an electric field. We all know that we define for a charged body that we create a Gaussian surface around it, and that the total flux of the electric field from that body coming out is equal to 4 pi q. And we do this through an integral of the electric field over the area of the Gaussian surface that surrounds it. The difficulty here is that we want to show an example of what happens for a local version of Gauss's law. And so, what is a local version? A local version would tell us what is the flux coming out, so to speak, of a point. Right, so how would we like this to look? Well, we're told that the local version of Gauss's law looks something like this, right? So it's the Laplace of E is equal to 4 pi of the volume density, and so we want to show why that is. Great. So from the regular version of Gauss's law, you want to show this version. So now what we can do is we can replace this 4 pi with P, or rho, times the volume. And what we can do here is just say, well, great, this is equal to the integral of rho times dv over the volume. And we need to do this because we initially equate, we initially are equating area with volume, so now we need to make some sort of change on the right side. So what we say is that the integral of the Laplace of E dot dv over the volume is equivalent to the total flux that we get just from the area. Now, why is that? Like, what's going on with this local version thing? Why is it that it's the Laplace of E? Well, it turns out that the Laplace of E is the Laplace of any vector, like E, is for a certain point, and we could say for a certain point how much of a source, how much field is coming out of it, or how much of a sink it is. So how much electric field is going into this point. And so if we know how much electric field is going in or out of every single point, then we can multiply this by the infinitesimal volume at that point and iterate over all of the volumes and get the total flux that's inside of here. And so that's what we do. So the integral over the volume is equal to the Laplace of E dot dv. So that's the flux, which is equal to the 4 pi times rho, the volume density times the volume. And now what we can do is just simply simplify. We've got integrals over volume here, and the volumes are the same. So we can just remove all of the volume terms. So now we have 4 times rho is equal to del E. And that's that. Bye bye. Hopefully it was helpful. Bye.